So how many of you have heard the term or have the word BI before in your life? BI for business intelligence? Just raise your hands. Today's discussion is essentially not as much about business intelligence, because that is a topic that is generally covered in high level courses, but we do want to introduce a few themes, and those themes are related to something which is core to business intelligence, and that theme is what we call data. So as professionals who work with technology and systems and computing, and as is appropriate in a course on introduction to computing, we need to understand, or at least think about or identify, certain very simple, very basic ground rules about dealing with data. In terms of context, I think there is a chain, and some of you may be very aware of this chain, some of you may have thought about this before, but I just wanted to make sure that we're all on the same page. When you think in terms of technology, so for example, if you take a look at your phones, if you take a look at your laptops, if you think in terms of your engagement and interaction, even with Zoom right now, this is essentially a engagement mechanism, an engagement platform in which you interact as an actor. You have a behavior and a role that you play, which we discussed last weekend. And then as part of that engagement and interaction, you generate data. So right now in front of your screen, you are seeing a presentation of information that is being streamed from my laptop over network to your machine. And within, even though it seems almost seamless, that I've turned on my laptop, connected to the network, put on Zoom, started a meeting, shared a meeting with you, and then you can see it and observe it on the other side of town or even on the other side of the planet. Even though this seems very, very seamless, there is an enormous amount of subsystems involved between your engagement and interaction with technology and the generation of data. In this specific case, what we're doing is simply recording it and we're seeing where does this take us. But in a number of other instances, we can actually use that data, deploy that data, and perform some analysis on it. And the objective of that analysis often is to go out and generate insights, and the objective of those insights is to go out and take action based on the information that we've analyzed. So this is the sequence, right? You're going from technology all the way up to actions that are driven by analysis performed on data that leads to direct insight. Right? There is a mindset, a very important mindset, and this is a mindset that you will come across often in your future careers, and that mindset is summarized by a very simple, very short and sweet single line, and that line is: good data drives decisions. So good data drives decisions, which is the piece where we speak about actions, right? So this is the context. So even though the slide deck says the I in BI stands for intelligence, that's the context in which we're having this conversation. This conversation is less about business intelligence or BI platforms, and it's more about data and how we should approach data when we work with it within our domain of being a technology professional. So for the purpose of this lecture and for the purpose of your weekend assessment and work that you have to do as part of your preparation for the weekend quiz, we want to look at two specific data sets. The first data set is an e-commerce store that I run. So I run something called financetrainingcourse.com, and I've been running that since 2012. It's been around now for about 11 years. And what you see in front of you is essentially sales data. So we sell computational finance models, study guides, online courses, lectures, videos, toolkits, hacks, all devoted and dedicated to one small field, and that field is computational finance. So within that field, for the last 11 years, we've sold to customers all across the world. And if you look at the data set that I've shared, so if you remember the package that went out to you, which was your second week assessment, which has been shared with you on this group, you will find that that package has two Excel files. One is a file that has the label FTC in it. FTC is my store. And the second is SBP's, State Bank of Pakistan's payment system report summary. So two separate data sets. But the first data set essentially shows you the breakdown on a month by month basis for sales that were performed, orders that were received by my store over the last 12 plus years. So you've got a couple of pieces here, right? You've got a monthly breakdown. So this is the sales that happened in month 10th in the year 2012. These are sales that happened in month 12 in the year 2022. These are the sales that happened in April of this year in 2023. This figure is the grand total of sales that were booked in any given month across the reporting period. And this is the sales that were booked in a given year. So you can clearly see that there is a trend here and there is a trend here, right? So this is the first data set, and we'll do some stuff to this data set as we move forward with today's class. And I may ask you to do other things based on what we've done today. First with this data set as part of your preparation, and then on the weekend quiz, I'll give you a different data set, and that data set would be very different from both the e-commerce store data set and the SBP data set. The e-commerce store data set and the SBP data set are just there for practice so that you get comfortable with the context of performing analysis on raw data. So that's one part. The second data set is the SBP payment systems series. So State Bank of Pakistan generates a payment system report, and this payment system report is updated on a quarterly basis. What it does, it tracks both the internet banking users. Just admit Navida. So what it does, it generates the comparison of users and customers who have been using internet banking, customers who've been using mobile banking, the number of e-commerce merchants that have been registered with the local banking system, e-commerce value in rupee terms, e-commerce volume in terms of number of transactions that were reported, value that was transacted on the internet banking system, value that was transacted on mobile banking application, and then the same values essentially expressed in dollar terms, as well as the USD PKR dollar exchange rate. So if you want to convert $1 into equivalent amount of rupees, this column here that you see here all the way for 2022, end of 2022, is that rate was about 223 rupees in the last quarter of 2022, right? This is the State Bank payment system series. So two systems, right? One is the e-commerce store, one is the payment system series. Now my question to you is, and this is something you should think about, you remember this framework where we spoke earlier about technology, systems, data analysis, insights, and action? I want to think a bit about what kind of process, systems, subsystems were deployed, what contributed to the collection of this data set. First, for the e-commerce store. So the e-commerce store that I have, if you think in terms of both technology and systems, as well as the data that you've seen, what had to be in place for us to generate and capture this? This is one part. And this is the first question to you. And the second question to you is, when you think in terms of State Bank's payment systems report, same question again. What technology, what systems had to be in place for this data to be collected and shared first with State Bank, and then as part of the payment system department quarterly report? What do you think? So what do I have in terms of data? This is, what is this? What does this $576 represent? This represent the total sales booked, total orders booked and received on the financetrainingcourse.com store, right? So what did it take to capture this data? What are the different layers of technology that you had to go through to make sure that this data could be captured? And you can start from the lowest level, you can end at the highest level. So at the lowest level, for example, let's take this as an example, right? At the lowest level, what do you expect to see? Where would somebody place an order for an e-commerce store? They'd place it on a laptop or a mobile device. So the first layer in this technology / systems conversation is your device. And that device has what? Has an OS. And on that OS, there is a browser. If you are working on a mobile device, and even if you're working on Windows 10 or Windows 11, there is some kind of an app or an application that you use to browse the store. But how do you browse the store? Between the OS, the browser, here there is a layer which is essentially your internet layer, which is the layer on which your data packets move back and forth between your device to the site of the vendor or the partner or the brand that you're dealing with, and then it sends data back, right? So but we ignore this for a second. So then on this app, what happens? On this app, there is essentially, in most instances, a website, and that website may be, let's say, built in WordPress. And on that site, there is a store, and that store may be built on something like Shopify or Ecwid or Magneto. And then that store has a checkout cart, and then that checkout cart is where you place the order. And when you place the order, that order goes where? It goes to a payment processor. It could be an aggregator or a consolidator. So for example, we use 2Checkout. You could very well have Verifone, which also owns 2Checkout. You could have PayPal. You could have your local internet payment gateway. And then once this order is placed, this order, the payment that is being made through, let's say, a credit card, this payment is processed, validated, verified across the entire financial system network. And then the order is confirmed. And once the order is confirmed, the site, for example, my site, goes out and ships the material to the customer, and it tells the payment provider, the payment processor, that I've processed and shipped the order, please process my payment. Then the payment is processed, and then the order is booked and recorded. So if you think in terms of the layer, just this layer, right? Just this layer, the technology / systems layer, there is a lot of stuff that's happening in the background that we take for granted. We take it for granted because it's completely transparent. We notice that that layer is not working, or we notice that that layer is there when things break, when things don't work. And when that happens, that's when you find out that there is a challenge or an issue, right? So this is the sequence, what you just seen from here to here, all the way. Let me switch the pen. So this is the sequence. And it's a fairly complex sequence that we had to go through. If you count the number of steps or the number of layers, this is one layer, the internet was the second layer, the browser was the third layer, the application was the fourth layer, the WordPress site was the fifth layer, the store was the sixth one, checkout was number 7, then payment was number 8, and then you had the order, which was 9, then there was this verification piece, so this is 9, this is 10, this is 11, and this is 12. There are about 12 layers through which data came through before we got to this point. Correct? Make sense? Do you follow? Yes? No? Maybe? So far so good? If this was the sequence that was followed for the e-commerce store, what do you think happened here with the State Bank Payment System series? With the State Bank Payment System series, things are even more interesting and complicated. Remember this piece? Just this piece, this payment processing piece? This piece. The financial system piece, right? So the State Bank Payment System report says that if you're a bank in Pakistan, and this is 1, 2, and you have an IPG, you have an internet payment gateway, and you have registered vendors who are registered as digital e-commerce merchants or vendors, and those merchant and vendors, so that's 4, and those merchant and vendors perform transactions and orders. You process those transaction and orders, but you also track them and record them, and you send them over to us as part of the payment system report. And then what we will do is we will run and generate the PST report once a quarter. So we'll aggregate this information that is at a prior layer aggregated by all the banks in the local financial system, and then we'll produce a report. So we have a sense of what kind of transaction activity, volume, rupee and dollar value is transacted on internet payment gateways, on e-commerce stores, on through e-commerce channels in Pakistan, right? So 2 different sets of data that are essentially generated by a very similar layer of technology infrastructure and systems and subsystems that then collect the information that comes to us, and then we process that information and then we run with it. Now, I think one big important question, one big important reason, motivation, and this is something that we ask, and we'll come back to this again and again. Why are we doing this? Why is this important? Why is this context important? This context is important for one specific reason, is that when we perform this analysis and when we generate these insights, our objective from both the analysis and the insight perspective is, are there any interesting, useful, relevant recommendations, actions that we would like to take, actions that can have a direct impact on how seamlessly these transactions flow, on how this underlying market grows, on what are the drivers of growth. And that's the objective. The objective analysis is not analysis for the sake of analysis. The objective of analysis is to see if we can identify recommendations that can improve the state of our current affairs, right? That's the objective. So actions that lead to improvement is the primary purpose of analysis. That's the primary motivation. That's the motivation that we're using in discussing, in debating, and in reviewing the work that we are doing right now in this specific session of our class. So now, what are the most common sins of data? When we work with data, when we deal with data, what are the most common challenges, issues, problems that we face when we work with data? What are some of the things that you should be aware of? And these are my list of pet peeves that I've sort of gathered and collected over 30 years working in the field, both as somebody who spends a lot of time with data, as well as a technology professional, a product developer, a founder, a user of technology. This morning, today, what just happened with our class of mic crashing, then restarting the machine, then Windows going into the update loop. This is again something which is ideally, there is a lot of data that is being generated as part of that transaction that goes back to Microsoft, and somebody should actually take a look into it and say, okay, this use case is clearly not working, so how do you fix that? But that's a different debate, and that's a debate that we'll come back to it much later in this course. So now, sins of data. What are the primary sins of data? I've got a 4x4 grid here, and I want to walk you through what each of these elements on this grid mean, right? So the first is noise. Noise is certainly information, but it's not useful information. Data is information, but it's useful information, right? And then both noise and data can be clearly visible. You can see, oh, this is visible noise, so I can just ignore that. It's obvious. Or it could be in the background, so it's not obvious. So right now I'm recording this session, and you can hear my voice, but if, let's say, there is a little child that is playing outside, or a baby that is upset and crying, or even a group of crows who are just upset at the cat that just ate a bird in the lawn, all of that would be background noise, and you would need to filter that out to get meaningful value out of both the current conversation and the current recording. Now, similarly, on the data side, a lot of times we look at data in a raw form because it's right there in front of us. But what does that data mean? What does it imply? What are the actions or recommendations that we can take that would be of use to people who are working with the data. And that is essentially the signal. That is the meaningful insight, meaningful intelligence that can be gleaned or dug out of the data. And generally, signals are not visible, signals are not obvious, signals tend to be in the background. So you actually have to you have to spend time, you have to allocate resources, use technology to first identify the signal, then to dig them out, and then to present them. And our objective, when we think of ourselves as technology professionals, our objective is not to work in the visible and obvious spectrum. Our objective is to work on what is there behind the data, what is there in the background, what is not visible, what is not obvious, which in most instances is the same. So I want to remember this. When I talk about the fact that the I in BI stands for intelligence, when I give you material to work with, when you yourself are doing work on a data set, you actually have to ask, you should ask yourself a very simple question. What's the underlying signal? I can see the data, but what's the underlying signal? If I want to add value, I need to be really, really good at identifying. I need to have the really, really comfortable with processes that we can use to first detect, then identify, then process, then parse, and then present and report signals that lie behind the underlying data set. Are we good? So far, so good? So if I take this a little forward, if I take this slide, right, this presentation, the noise, data, visible, background, obvious, raw, filter, signal piece, if I take this forward to the next stage, the next stage is that there are, when I think in terms of data and I think in terms of analysis, again, same grid, similar grid, but I've changed, now sort of advanced the labels to the next stage. Some data is just FYI. This class will be held on Zoom is FYI information, for your information only. The class has been delayed by half an hour because of the Windows update loop, FYI information. But some data is actionable. Your average grade is above the average. What is that information? Is that FYI or is that actionable? Your average grade is below the average compared to the class, compared to a benchmark. So that's one specific instance. But take this a little forward and think in terms of other applications. So when we started this course all the way back 3 weeks ago, we spoke about going from DHA, EMAR to IBA. And we said there is a journey, and that journey, best case time, I don't know how many of you remember that, best case time was 38 minutes, worst case time was 55 minutes, right? If I think in terms of this as data, and I think in terms of action, one action that I can possibly perform is how do I model that journey? So if I leave at a given specific point in time, can I build a model that can give me a sense of what the prediction for my ETA, my estimated time of arrival at IBA would be? With respect to this course, the quiz and assessments that you've gone through 2 of them, right? You now actually have a fairly decent model in your head of what type of questions and what type of work to expect in the weekend quiz. You know for a fact that the preparatory material that we've given you, the data set and the guides and the model building exercise that you have to do, all of that is prep work. The actual data set is going to be different. The actual set of questions is going to be different. The actual framework that we use for testing purposes is different, because what we essentially doing with the pre-release materials, with the study guides, with the models that you work with prior to the quiz, is we are getting you to practice a given skill set, and then we want you to apply that skill set to a different data set so that we can test your ability to generalize. We can test your ability to build an internal model of the concepts of the material presented in the class so that you can then deploy them to a framework, to a data set, to a context, to an instance that you haven't seen before. Right? And how did that come about? That came about essentially you had data, you use that data to build an internal model of expectations, and that internal model of expectations translates into actions that you do, that you use to score higher in the weekend assessment. So far, so good. Now, if you take this to analysis, analysis could be fairly superficial. In the last 10 years, the Pakistani economy has gone in a certain direction. In the last 10 years, Windows has done X number of updates. In the last 10 years, we've clearly seen that the first release of Windows operating system, the first new release of Windows operating system has challenges and issues. So it's not best to upgrade to the most recent release as quickly as possible. It's best to wait till they work out all the kinks. This is all of this is what I would essentially call superficial analysis. What would intelligence be? So if I take the example of building this model for anticipating and expecting what to expect for your weekend quiz, if you build the model correctly, you should actually be able to create a guess of what to expect. What specific questions should we expect to see given the material that we've seen and the data set that we've seen so far for this course, right? So that would be intelligence. So data can come in multiple shapes and form. One is for your information, one is actionable. We need to focus on a bias for action. And the bias for action, the ability to act on information, on intelligence, is directly related to our ability to detect the signal and use that signal as a benchmark for identifying what kind of actions need to be taken. So when you make the commute from main campus to city campus, there is a couple of areas where you will get caught as far as traffic is concerned. So if you take University Road, you're going to get caught at Baitul Mukarram. You're going to get caught from the point between Dunkin' Donuts and Hassan Square, between the planetarium. So there's a patch there. And then you're going to get caught at Sabzi Mandi, old Sabzi Mandi, right where I think it was called Chandni Chowk Cinema. The old Chandni Chowk Cinema patch has been dug up and has become a huge nightmare. So now, if I leave home or if I leave the IBA campus at, let's say, 8:30 in the morning to go to city campus, in most instances, I have an option to take a left from Baitul Mukarram, or I have an option to take a left at Stadium Road, right next to Expo. But if I find out at Expo Center that Stadium Road is closed because of ITCN or because of a cricket match or because of VIP movement, then I'm stuck. Then I'm married to my choice of going through Sabzi Mandi. And at 8:30 in the morning, I can tell you that Sabzi Mandi is not the most preferred choice of routes that you can take to get to IBA. But at that point in time, my options are limited. There are not that many exits that I can take that'll make it possible for me to get out and get to IBA through different paths. So intelligence, actionable intelligence, is only useful if you receive it, if you get it, if you have it, if you can generate it in time. If it comes late, it is no longer actionable and it is no longer intelligent. Then it just becomes part of history. It becomes part of the past. So your analysis needs to, in fact, in a lot of instances, you will find that your analysis needs to be done in a time-sensitive fashion for it to be useful for people who need to act on it. So here's the model. Here's the essence. Here's the truth table for the two slides that we've presented before. We generate data. In most instances, useful data that we are using to analyze, has an underlying signal. Depending on how much time we spend with that data, depending on how much time we've been running this analysis on data, we can even build a model that allows us to predict, forecast, and extrapolate that signal. And in most instances, this combination of signals and models leads to actionable intelligence. And our objective as computer scientists, our objective as technology professionals, is to figure out how to make this transformation, this process that takes raw data and converts that into actionable intelligence, as seamless, as powerful, and as fast and efficient as possible. So now, quick question. You saw the SBP payment system report. I shared that with you earlier on the slide deck, and you also have the data set in front of you. You have the Excel file. You can open that Excel file. I've run some analysis on that Excel file, and I'm putting this in front of you. So this is essentially a trend from the State Bank of Pakistan's payment system report, and this trend presents what? It presents the digital e-commerce transaction volume on a quarterly basis in dollar terms. So all of these values that you see here, this number, this number, this number, all of these values that you see here are in USD terms. If I'm right, yeah, they're all in US dollar terms. So for example, in 2017, in Q4, the total sum of all e-commerce transactions that happened across IPG gateways, internet payment gateways in Pakistan, was about $40 million. And in 2022 Q4, which is the end of 2022, which is essentially December 2022, so not December, so October, November, December, 3 months, 1 quarter. In 2022 fourth quarter, that same number was about $153 million. So this is analysis, is it? It is analysis, but is it useful? Does it tell you anything? You can see there's, I've tracked growth, so I can tell you that 19, grew about 15% compared to 2018, and then 2020 grew about 27% compared to 2019, and 2021 grew by about 88% compared to 2021. And then 2022 growth has clearly slowed down. So now, if you had this trend, you can certainly make a forecast on what the number for 2023 would look like. But is this like useful analysis? Would you say that you can detect a signal? So this is a signal, this is a growth signal. You've at least done this part. But can we do a better job than this? Is there any actionable intelligence here? Is there any policy recommendation that you could make based on the information that you see here? Is there any insight? Is there any intelligence? It is analysis. I've taken the 22, 23 rows you had, and I've compressed that. So from an information compression point of view, in terms of summarizing the information that was available to us, this looks decent. It's okay. It's useful. It's better than looking at those 22 rows and trying to figure out what do they mean. So at least I've sort of summarized. It's a good summary, but is it intelligent and is it actionable? That's the question. Question you should ask yourself. Is what we see in front of us intelligent and actionable? And if it is not, what is it that needs to change? And that's the intent, that's the objective of today's class, is to figure out, if I get a raw data set, how do I take that data set and convert that into something which would represent intelligent analysis and could ultimately be used for the purpose of actionable intelligence. So we established this point that analysis is not always intelligent, analysis is not always actionable. What can we do to fix this?